Module 16, yeah. Troubleshoot static and default routes. Module of this objective. Module objective for this topic. Troubleshoot static and default routes. Here, there are two topics. Packet processing with static route. So this will explain how a router processes a packet when a static route is configured. Next one, troubleshoot IPv4 static and default route configuration. So here, this topic will explain about troubleshoot common static, yeah, and default route configuration issues. So it will explain about troubleshooting common, yeah, in the static and default route configuration issues. (16.1) packet processing with static routes. Okay, packet processing with static route. PC1, yeah. If you look here, PC1 based on this explanation based on this diagram, yeah. Okay, PC1 addresses a packet to PC3 and send it to the default gateway address. When the packet arrives on R1 G000 interface, R1 decapsulates the packet and search the routing table for matching destination network entry. If the destination IP address matches a static route entry, R1 will use the static route to identify the next hop IP address or exit interface. Does not match a specific route to the destination network, then R1 will use the default static route if configured. Does not match a route table entry, then what happened? R1 will drop the packet and send an ICMP message back to the source, for example, PC1. So assume R1 match a routing table. It encapsulates the packet in a new frame and forward it out of interface as 010 to router 2 or R2, sorry. And then R2 receive the packet on its S010 interface. After that, it decapsulates and processes the packet the same way R1 did. When R2 finds a match in a routing table, it uses the identified next hop IP address or exit interface and sends the packet out of its interface at S011 towards R3. After that, R3 receives the packet. Okay, R3 here. And decapsulates it and searches the routing table. The destination IP address or PC3 matches the directly connected G000 interface. Therefore, R3 searches the ARP table for the layer 2 MAC address of PC3. If no ARP entry exists, then R3 sends an ARP request out of the G000 interface. PC3 responds with an ARP reply containing its MAC address. R3 encapsulates the packet in a new frame and uses the PC3 MAC address as the destination MAC address and the G000 MAC address as the source MAC address. The frame is forwarded out of interface G000 at PC3 and PC3 receive and processes it accordingly. Troubleshoot IPv4 static and default root configuration. Network changes. Network fail for a number of reasons. An interface can also fail. A service provider drops a connection, and then links can become oversaturated. An administrator may enter a wrong configuration. This is reason why network fails. So network administrator are responsible for pinpointing and solving the problem. To efficiently find and solve these issues, it is advantageous to be intimately familiar with tools to help isolate routing problem quickly. So common troubleshooting command. First, we use a command ping. So ping is a layer 3 instruction connectivity to the destination. So extended ping provide additional options. So next we can use trace route. Okay, this will verify a path to the destination network. It uses ICMP echo reply messages to determine the hops to the destination. And next command, we can use show IP route. So this command will display the routing table. And this command also used to verify route entries for destination IP addresses. And another command, show IP interface brief. So it displays the status of device interfaces. This command also used to verify the operational status and IP address of an interface. And another command, which is quite popular, we use show CDP neighbors. So this command will display a list of directly connected Cisco devices. It also used to validate layer 2, layer 1 connectivity. Solve a connectivity problem. Connectivity from PC1 to PC3 fails. So this explanation reflect to this diagram. Yeah. So extended pings from R1 at G000 interface to PC3 is failed. So ping from R1, for example, S010 interface to R2 are successful. And also ping from R1, for example, S010 interface to R3 are also success. So R2 routing table reveals the problem and the incorrect static route is removed. So referring to this highlighted color here, yeah, the yellow one. So new static routes solve the problem. So we use IP route 172.16.3.0, 255.255.255.0. That's the subnet mask, and this is the next IP 172.16.2.1. Okay, so 6.3 module practice and quiz. So here there is a packet tracer. If you look into our net packet, you will find this activity. So you can have it and try. Yeah. So packet tracer troubleshoot static and default routes. In this activity, you will troubleshoot static and default routes and repair any errors that you find. First of all, troubleshoot IPv4 static routes and also troubleshoot IPv6 static routes. This will including also configure IPv4 static routes and configure IPv4 default routes and also configure IPv6 static routes. Okay, there are also another physical mode packet tracer. You can find in our net packet. Troubleshoot static default route, physical mode, yeah. And then lab troubleshoot static and default route. And in this packet tracer physical mode activity, in the lab, you will complete the following objective. First, evaluate network operation. Next one, gather information, create an action plan, and also finally implement correction. So this will help you to solve the problem also. Yeah, so these two very important. Okay, what did I learn in this module? Basically, if you look properly, yeah, the statement that written in this slide. First, a host send a packet to another host and sends it to the default gateway. Okay, when the packet arrives on router interface, it decapsulates the packet and searches the routing table for a matching destination network entry. If the destination IP address matches a static route entry, so what happened? The router will use the static route to identify the next hop IP address or exit interface. What happens if it does not match a specific route to the destination network? Then the router will use the default static route if configured. So does not match a route table entry. Then the router will drop the packet and send an ICMP message back to the source. So what happens if the router match a routing table entry? Then router encapsulates the packet and forward it out of the appropriate interface. So the packet is forwarded from router to router until it reaches its destination network. So when the packet reaches the destination network, that router will search the routing table for a match. When destination IP address matches a directly connected Ethernet interface, the router searches the ARP table for the layer 2 MAC address of the destination IP address. If no ARP entry exists, the router sends an ARP request out of the internet interface. The destination host respond with an ARP containing its MAC address. The router then encapsulates the packet in a new frame. It uses the MAC address of the destination host as the frame destination MAC address. And then the MAC address of the router Ethernet interface as the source MAC address in the frame. The frame is forwarded out of the appropriate interface. So when the packet arrives on the interface network interface card NIC, interface of destination host and is processed accordingly. All right. Okay, common iOS troubleshooting commands. In order to troubleshoot IPv4 static and default routes include ping, trace route, show IP route, show IP interface, brief, show CDP neighbors detail. Okay, here are the command. Yeah, the common command for troubleshooting commands. Yeah. All right. Thank you for time and listening. Bye bye. Assalamualaikum.